And we have a few questions on here. Some of them, actually, one is a horizontal line. We did a vertical line problem. One is just a setup where you don't even have to solve for the answer. But this one we actually will solve for the answer, but it is calculator. So you ask the question, does it really matter if we use right minus left or top minus bottom? It does depend on the orientation because sometimes it gets too complicated, like the previous example that you were just asking me about, that one region. But in this case, you could do either a top minus bottom or a right minus left. It also depends on what they give you. So if you take a look here, it says find the area in the first quadrant bounded by the two equations. These are already solved for you for x. So it's already set up for you. The only thing you need to do is remember, this is just a variable. So if you plug those in, you can still find the point of intersection. Here you can see what this point is, and if you look at the graph, you can see what this point of intersection is. So everything is right there for you. You may as well just use the setup that you're given. Now, if it's given to you in terms of y is equal to, because that's a with respect to x, and they ask you with respect to y, you don't have a choice. But if I just say to you, find the area, take a look at what you're given. In this case, this is already solved for x, this is already solved for x. And because the graph is very clear, this is labeled. Okay, so that means this one is on the right, and this one is labeled, this one is on the left. I can see everything clear as day. All I need to do is write my integral. So it is really important that you take a look at what you're given and decipher the information. Because now I have my bounds. My bounds go from 0 to pi over 2. So, and I can do all that in the calculator. So if we're asking you for the setup or the integral, we're going to say that the area is equal to the integral from 0 to pi over 2. My right is the sine of y minus the quantity of 1 minus the cosine of y dy. Here, I don't really think it's going to be beneficial to me because both of these equations are already solved for x in terms of y. To turn around and solve them for y in terms of x, it's just more work. And what's going to happen if we have more work like that? The odds are we're going to make a mistake. So, yeah. So just see what you're given. So now I'm just going to go into the calculator and type in what I wrote. Okay, so let's hope I did it right. Done. That's it.
It is so easy.
It can be easy, but you have to make sure, like the previous problem that we just did, it was both in terms of x and in terms of y, but the directions did say that you need to solve with respect to y. So it's very specific. If it just said find the area and it doesn't matter, if Elizabeth does it by with respect to x and you chose with respect to y, you should get the same answer if you don't make a mistake. Right? Okay. Any other questions before we talk about these last two problems? Yes, sir?
Is it a big deal if you mix up right and left?
Yeah. Your answer, if you do left minus right, your area will be negative.
But then you just delete the negative sign.
Yeah, but how are you going to know that if you mix them up? So that's why it's important that you sketch the graph or you take a look at it on the calculator if you're allowed to use a calculator. I'm pretty sure your quiz, when you take it, is going to be all calculator. Okay, so here it says express the area of the shaded region in the given figure as a sum of 3 integrals. So it already tells you that you have to have 3. All right, so you need to take a look. Quick question. Is this going to be with respect to x or with respect to y? How do you know that? Yeah, it looks more like a top minus bottom. That's the easiest way to do it, and it's definitely not vertical. Okay, so can I just say in this first region, when you're taking a look at this shaded region, can I go from 0 to 5 of g of x minus f of x? Why 0 to 3? The bounds change. Okay, so that means it already gave you the hint. It's 3, right? Okay, so you told me that there is a cutoff at 3. So right here. Okay. And then we've got what? What's my top from 3 to 5? Okay, it's g of x, but what's my bottom? 0, so it's this. Okay, so here's my second section, and then my third is what? From 5 to 9, and we need to look at what's top and what's bottom. Okay, so going from the left, we have the integral from, you told me 0 to 3. What's my top? G of x minus f of x. And this is just dx. Okay? Plus. Then we have the integral. You told me this got broken up here. So it's from 3 to 5. What's top? G of x minus 0 dx. I know that most of you will say, well, this just goes away, but write it there anyway. Be consistent, top minus bottom or right minus left. Okay, that way you're not forgetting anything, especially when we start dealing with volume in the next section. And then the last one is from 5 to 9 of what? Yep, 0 minus g of x. I'm going into my graph here, dx. So these are your 3 sections. Now, is it always going to tell you how many sections? No. Okay, but this is just sort of cue you up to say, okay, you need to pay attention. Okay, because the first mistake that people make is they go, oh, 0 to 5, g of x minus f of x, but you're forgetting this small section right here. Okay, it's not shaded. Okay, last problem. In the previous section, you guys were given a half of a parabola and a bound from 0 to 2, I think. And you had to find the vertical line, x is equal to k, where that area was cut directly in half. So remember that we wanted the area on the left to be equal to the area on the right. So in this case, they want to find a horizontal line that does the same thing. So instead of it being like this and cutting the 2 areas in half this way, you're going to cut the 2 areas in half. You're going to have a bottom area and a top area, and you want them to be equal to each other. So that's what we're looking for. But first, we actually need to graph. So what do we have here? What is this? This is our first graph. This is a parabola. Okay, so we've got 0, 0, 1, 1, 2, 4, and we're going to sketch this to the best of our ability, right? Okay, parabola. Not perfect, but good enough. Then we have a second equation, y is equal to 4. What is that? Don't say straight. Horizontal line here. Nuts. Okay, there's my line. All right. And then it says x equals 0. What is that? Oh, it's the y-axis, so it's right here. Okay. So we are bounded here, here, and here. So does everyone see the region that we're looking for is actually right here? Everybody good?
Why do you only look at that half?
It's based on the bounds. So it's, I mean, it doesn't matter, because it could be the other side too. But they're saying that it's not this whole piece, it's just the half.
So when you give the answer, should you give like positive and negative form?
No, because they really just want to know what's the horizontal line, so that's what we're going to find.
Okay.
But, so, because what we're looking at, if you did this side, what's going to be your right? It's going to be the vertical line of x is equal to 0.
Yeah.
On this side, what's going to be your right? It's going to be the quadratic. And then your left is going to be, so it's just going to be turned around,
Yeah.
but it's not really going to make a difference because we're trying to figure out what is that line that's going to cut those 2 areas in half. And the reason why it doesn't make a difference here is because this is, a parabola is symmetric.
Yeah.
It's supposed to be if it's drawn right. But that's a good question too. Okay, so this is what we're looking for. We're looking for some given line, and I am just arbitrarily putting a dotted line right here. It might not be in the right spot, but we're trying to figure out what this is. So this is our quadratic. This is our bound. Okay, and then this is our bound. So that gives us the green region. So what we want to do, and because this is a horizontal line, it's still going to be right minus left from bottom to top. But now we're splitting this in half, and this is our line, y is equal to k. This is the unknown value. So this is 0, and this is 4. So we want this portion to be equal to this portion. So the area under the curve, from where to where? Whoops. Yes, from 0 to k is what? It's right minus left. Oh, what am I missing? What do I not have? If I'm doing right minus left, my equation has to be in terms of what? I got to write it as x equals. So we have y is equal to x squared. Now what? Okay, x is equal to the square root of y. Now, isn't this plus or minus? Plus or minus. So this addresses the question that Elena asked me. Now, I chose the positive side, but she said, what if, well, how do you know it's not the other side? Ideally, it's only half. But if she chooses the left side, what's her equation for this going to be? Negative square root of y. So do you see how it would even out? Okay, so because I chose this one, I'm only choosing x is equal to the square root of y. I chose the positive side. Why? I don't know. Because I like the right side? I have no idea. It doesn't make a difference. Okay, so this is the right portion of my graph. What's the left? What's bounding me on the left of my green? Yes, but more specifically, x equals 0, right? Correct? Okay, now this should make more sense. I want the right minus the left. So this is going to be, can I write this as y to the 1/2 minus 0 dy? That's just this bottom part. This has to be equal to the integral from where to where? K to 4, nice. Of y to the 1/2 minus 0 dy. And I'm just being consistent. This is the right minus the left, right minus the left. Okay, so here's the deal. We need to integrate y to the 1/2. What is the integral of y to the 1/2? 2/3 y to the 3/2 to be evaluated from 0 to k is equal to 2/3 y to the 3/2 to be evaluated from k to 4. Okay, folks, we talked about this. What happens to the coefficients? Yep, they drop out. Because if I move this one here or this one here, they're going to cancel. Okay, so now we need to evaluate. This is k to the 3/2 minus 0 to the 3/2 is equal to 4 to the 3/2 minus k to the 3/2. All I did was use f of b minus f of a. Okay, this is k to the 3/2 is equal to 4 to the 3/2 minus k to the 3/2. What do I do? Add k. So I have 2k to the 3/2 is equal to, what's 4 to the 3/2? What does that mean? Okay, 4 cubed squared. Oh, okay. So you could do it one of two ways, right? You could take 4 to the 3rd power, which is 64, and take the square root, or you can take the square root of 4 and cube it. Does it matter? Aren't they both 8? The square root of 4 is 2. 2 cubed is 8. 4 cubed is 64. What's the square root of 64? Okay, so they're both 8. Doesn't matter. Sometimes it's just easier to do one over the other. Okay, now what? Divide by 2. So k to the 3/2 is equal to 4. How on earth do I get rid of the 3/2?
Square 4.
Okay, can I do it quick, like faster? Like in one step? Yeah. So instead of taking both sides to the 3/2, you take them to the 2/3. So this is k is equal to 4 to the 2/3 power. And the reason why I asked is, can I take the cubed root of either 16 or 4 without a calculator? No. This is my answer. This is my horizontal line. But if I look 4 to the, what is it, 2/3? 2.5. So this is in the wrong spot, right? But it's still the same idea. It's somewhere in the middle. This is more of a graphic than accuracy. Okay. Does anyone have any questions? Horizontal, vertical. Yep.
We're allowed to use a calculator for this type of question?
Yes. Or if you're not allowed to use a calculator, you would just give it as a rational, that type